Hey guys, in this episode I'm going to show you how I make this spring pocket. And basically on my international or the Cabover, you have these springs with these U-bolts that go through two springs, and that's how the cab is attached to the frame. So to do that, now I've already painted these. There wasn't anything exciting about that. It's black paint, so I didn't worry about recording that. But what I am going to do is I'm going to show you the process that I use to make this little spring bucket, and I've got to make 8 of them for top and bottom. And what I'm going to do is I happen to have this bar. This is 4140. It could be made out of A36 mild steel, for that matter. You know, these were stamped. I don't have a way to stamp this, but I do have a way to machine this. And this is 2-inch 4140. So I'll show you how I make this. See, it's got a pocket and it's got a little lip back here. So I'll machine it just like this. So to get started, this is 2 inches. So this is just under 2 inches. So I may not have a nice pre-finish on the outside because I'm using material that's literally the same size. So I'm going to do a quick sketch and give me some basic dimensions. Now I know the U-bolts that are coming through these are 1/2 inch. I think what I'm going to do on this, I'm just going to put like a 5/8 hole through this. Mainly because I'm being lazy and I happen to have a 5/8 drill in the machine. So we're going to mark that as 5/8. So, but I do have this little, you can see it, this little ridge here. That is 1/4 inch. So profile view of this. That's 1/4 inch. And it's like 1/8 of an inch for the underside bevel, if you will. So I'm just going to mark that as 125. And my inside diameter of this pocket is 0.85. I'm sorry, 1.85. That's my idea of that. 2 inches is my all right, I'm gonna go to the computer. I'll show you all how I do this in SolidWorks, and then we'll come back to the machine, set the machine up. We'll run one of these, kind of test it, go from there. Okay, so now that I have my program set up in the machine, I double checked the program on the computer. When I did that, after I set it up, I went ahead and corrected the tool numbers in the program so that if I need to make a quick change, I don't have to go through there and re-update my tools. So I do that for a couple things. One, to keep me from crashing the machine or help do that. But then it just kind of helps me verify everything as well. So now I'm going to run the program, and every time I run a program, I'm watching it like a hawk for the first time, make sure I don't crash. So far, knock on wood, I've been doing this for quite a while, and doing it that way has really helped me not crash the machine. So I'm going to run this real quick and we'll see how the part turns out. I got the first two ops done. I'm going to just do a quick check visual just to make sure that everything's going like I think it should be done. One thing you may or may not be able to see, even though I did a skin pass over the top, I wasn't really worried about the outside because I'm going to sand these and paint these, so being the same dimension was relevant. So everything looks good so far. The hole is where I need it to be, and we're going to see how the rest of it goes. Well, here's a prime example of why you should always run these programs really slow. I broke my insert because Mastercam, in the program itself, Mastercam actually did not create a withdrawal code. I was too busy watching the machine instead of looking at the code. But I don't know why Mastercam does this, but they've done this several times. Technically, this is a crash. It's not a bad crash. I just broke my insert, but a crash nonetheless. But you know, that's a carbide bar, and luckily, as soon as I heard it crunch the insert, I hit stop, so or feed hold, and so this is just one of those situations that you're always watching and looking for. So I'll go back to the program, see why Mastercam did this, and figure out what setting that I may have selected that caused it to do this, and then we'll proceed. But for the most part, it was pretty close to being done. But now we're back to the drawing board. Okay guys, so I have corrected the program. Don't know exactly what was going on, like I said last night. Not 100% sure what that was all about, so I've got it corrected. I actually ran all of these pieces last night after I corrected it, but for some reason somehow I selected slow-mo a slow-mo video, so it just basically I couldn't use it. So I'm going to run it again for you and show you it coming off the machine and being correct. Now, if you'll notice, I was not running that at full speed. This is the first time I ran the machine today. I always, if I leave the machine like overnight, or if someone comes in before me in the morning, I don't know, they may not have changed something on the machine, but I'm always super cautious. But so if I were to run the rest of these, I would run at full 100% rapids and feeds. So, but here's the extra one that I did basically, but I just want to show you that the program is proven. And yet, a lot of people are more machinists than not. Like if they are the last to touch the machine, they come in and hit that button and go. I don't do that. I don't know why. I just more cautious, if you will. So, but there's the extra pocket, and we go on to the next project.